Okay, suppose that we are in this situation. We want to draw tangent at the extremities of latus rectum. Okay, we want to draw a tangent at the extremities of the latus rectum of an ellipse. Okay, now the idea is like I want to draw a tangent at the extremities of latus rectum, and I want to see the tangent will meet at, or if you want to go with tangents also, I'll go with tangents. So I want to find out where these two tangents will intersect. Okay, so suppose that this is your ellipse. Suppose you know that it is y-axis, you know that it is x-axis, you also know that it is directrix 1, it is directrix 2. So the idea is I want you to tell me ki suppose this is the latus rectum. Okay, so you know that ellipse is an symmetric thing. So suppose that if we want to drop a tangent to this point, it will meet somewhere. I want to drop a tangent at some point, it will meet here. So I am interested in finding this point of intersection. I am interested in this point. Okay, now how we will calculate? Let's see. You know that we are talking about latus rectum. So it is a chord perpendicular to the axis of the ellipse passing through foci. So who is S? S is AE comma 0. Now let's write down the standard equation of ellipse: x square by a square plus y square by b square equals to 1. So first I'll find out this point, end point. So you know that x coordinate will remain the same, a square e square by a square plus y square by b square equals to 1. A square is square gone. So y square we got 1 minus e square into b square. Now this is not cool. So what I want to do is, I want you to tell me, have you ever seen like A, B and E connected together in some relationship? Yes, you know that it is 1 minus E square everywhere. The thing which is bigger will go inside. So for this case it is A. So A square will go inside. So we have B square. So can I say that 1 minus E square will be equal to B square by A square? So let's simplify. So it would become b square a square. So it would become what? Plus or minus b square by a. Just tell me, right or wrong. So this thing will become ae comma b square by a. Point B will become ae comma minus of b square by a. I hope till this part you guys are okay. Correct? Now you know that it is symmetric. So if you will go with one tangent also, you can find out the point of intersection. The point, it will intersect at x-axis only because it is symmetric. Tangent is also symmetric and ellipse is also symmetric. So I'll go with tangent A. So if you have a point on the curve, how we used to write down equation of tangent? T equals to 0, done. So can I write x x1 plus y y1 equals to 1? Correct? Now you can play fruit ninja. E say E gone, b square gone. You know that it will intersect at x-axis. So can I say that y coordinate will be 0? Correct? So like if you are not comfortable, I'll write again. So we got x e by a plus y by a equals to 1. So we got our first equation, tangent 1. Now I'll go with tangent 2. Okay. Now look at this. So for tangent 2, I'll go with this point. So t equals to 0 again. X x1 a e by a square plus y minus of b square by b square a equals to 1. This thing gone है ना, this thing gone. So x e by a minus y b by a equals to 1. B square is vanished. Okay, so we are left with y only. Now look at this, you got both the tangents. Now I want to find point of intersection, so we have to solve this one. So can I add both the equations? So if we will add, we will end up having what? 2 times x e by a is equal to 2, because this component and this component is same, so it will become 0. So 2 gone. So x equals to what? A by e. So can I say that the tangents at the extremities of latus rectum of an ellipse intersect on the corresponding directrix? Means if I'll use this point, it will intersect at this directrix. If I'll be using this point, it will intersect at this directrix. I hope the idea is clear.